PCMINR.com, and you're watching this video on projectiles given horizontal projection by Sony Gupta. So in this video, let's look at the projectiles, how they behave when they are given a horizontal projection. First of all, what is a projectile? See, it is just a body which is thrown with some initial velocity with the horizontal direction. So we don't give it any velocity in a vertical direction, and later it is allowed to fall under the action of gravity alone. Then that is given the name of a projectile, and the path that the projectile is going to follow is known as the trajectory. So let us look at the case when it is given a horizontal projection. The best example would be like, suppose you're standing on the top of a building, right? So let this part be the height of the building h. So I take the height of the building h, and you're standing here and you drop a ball. It is obvious you're going to drop it with just giving it an initial velocity along the x-axis. You will give it a velocity like this. But we know the path that it is going to follow is going to be something like this. So it's going to fall following a parabolic path. Now, as it follows a parabolic path and it falls down, so this shows that once given an initial velocity, it is going to cover a motion in a plane. This is actually the example of a motion in a plane, because it is going to cover the distance along the x-axis as well as y-axis. So let us look at both the sides. First, we are going to talk about the x-axis motion and then the y-axis motion, and accordingly we are going to find out the time of flight, like how much time this projectile takes to fall down, and what is its horizontal range. That means how far it falls from the base of the starting point. So this way, though I have the distance x, but I will consider this distance to be r, that's the range. The range means how far it falls from the base of the building. So first thing is, let's find out the time of flight. But to find out the time of flight, you will need to define a couple of things in the beginning. First, that u that we give its initial velocity is going to be along the horizontal. So u, which is supposed to have two components, ux and uy, because it's a motion in a plane, out of that it is only given a horizontal velocity. So uy is going to be 0. So I'm saying for the initial velocity u is the initial velocity, its x component is there and uy is 0. And what is special about the x component? That this is going to remain constant throughout the motion. And why is that? Because velocity changes only when a force acts on it, but there is no force acting along the horizontal. Therefore, we would say that the velocity ux remains constant throughout the motion. But uy, though initially it was 0, it will keep on increasing, and this keeps on increasing because of the force of gravity, because it has a force of gravity acting downwards. And since ax is 0, this gives you another thing, that ax is 0. Because ux is constant, ax, acceleration along the horizontal, will be 0. And ay, the acceleration along the vertical, is going to be g. That is the acceleration due to gravity. So now we are ready to find the time of flight. The time of flight, kids, please remember that small t we use is for any time interval, but we will use capital T for the time of flight, means the total time taken when it was dropped till it reached here. This whole thing took it a time, capital T. For that, we'll consider the vertical motion. Now you have done the equation, s is equal to ut plus half at square, right? So I will take the vertical part of this motion. The displacement along the vertical is going to be h, and that is going to happen during the complete time interval. So u, initial velocity, is only u or ux, it doesn't matter, you take it as ux or uy into t plus half gt square. I've replaced small t with capital T because I'm taking the total time of flight, because that is the time in which it will cover the complete height of the building to fall down. Now this was 0 because uy, I've marked it 0 here, and plus half gt square. So that gives me a straight equation. Half gt square is equal to h. So what is going to be t? Therefore t is going to be root of 2h by g, right? Just rearrangement of the terms. So the time of flight depends only on the height from which you drop the ball. So time of flight is going to be different. If you drop it from the 5th floor, you drop it from the 10th floor, you drop it from the 15th floor. Every time the time of flight will be different. Now let's move on to find out the horizontal range. How far does it go? So how can we find out the range of this projectile? Now again, the range will be covered in the total time of flight because this distance it is going to cover when it falls down. So this will be covered in the total time of flight t. So we are going to use the horizontal equation of s is equal to ut plus half at square along the x-axis. So it will be x is uxt plus half axt square. Now I'll put the values. X, the horizontal distance covered, is the range r, that is equal to uxt, which was u, times t, it's going to be capital T, plus 0 because there is no acceleration along the x-axis. I hope you remember in the beginning I said the velocity along the horizontal is constant throughout, so ax is going to be 0. So r is just equal to u times t, and t we just found out is 2h by g. So how far the object falls depends on two things: the height from which you throw it and the initial velocity, how hard you throw it, like what is the maximum velocity you have given. So if you give it throw it with a greater velocity, it is going to fall farther away. Now let's find out what is going to be the velocity of this projectile at any instant. Now suppose we take it at any point, it's going to be like along the tangent to this curve. So let's say v, the velocity is always along the tangent. It will have two components, vx and vy. Now these two components will give us the net velocity at any instant because it is going to change. So Vx is going to be ux only because we have initially defined that horizontal component of velocity is not going to change. So that is just equal to u. But the vertical component of the velocity is changing every instant because of the gravity. So Vy we can calculate using the equation u plus at. So along the vertical, uy was 0. Initially, we did not give any velocity along the horizontal, plus gt. Therefore, the vertical component of velocity is gt. Therefore, by vectors, you already know how to find the magnitude of this net velocity. It's going to be equal to the sum of squares of the two components, vx square plus vy square. So you just get v, the velocity at any instant, is equal to u square plus g square t square. So I hope you've understood completely about the projectiles which are given a horizontal projection. So when you throw something from the top, giving it an initial velocity only along the horizontal, that is a horizontal projectile. And we found out the time of flight, horizontal range, and velocity at any instant for this. I hope it is clear to you. Please like and subscribe to our channel and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.